Today we're going to talk about composite functions. So before we get into composite functions, let's review just evaluating functions. So notice you're given f of x equals 2 times the absolute value of x squared plus 1 minus 2. And then you're given that g of x equals the square root of 2 minus x and then plus 4. So let's look at part A first. It's saying find f of 0. So that means I'm going to go up to my f function. Every time I see an x, I'm going to replace it with a 0. So I'm going to get 2, 0 squared, plus 1, and then minus 2. So now if I simplify that, I'm going to get 2 times the absolute value of 1 minus 2 equals 0, then 2 times the absolute value of 1 is going to be 2, 2 minus 2 is going to be 0. So f of 0 equals 0. Part B, it's still telling us to go to f, but now I'm replacing x with a negative 3. So I'm going to have 2, negative 3 squared, plus 1, minus 2. Alright, so let's go ahead and simplify. Negative 3 squared is going to be 9. 9 plus 1 is 10. So we're going to get 20 minus 1, which is going to give me 19. So f of negative 3 equals 19. Now C is telling us to go to my g function. So this time I'm going to refer to g. So g starts with the square root of 2 minus negative 7, and then on the outside plus 4. Well, that double negative right there will turn to a positive. So I'm going to get the square root of 9 plus 4. So 3 plus 4 is going to give me 7. So g of negative 7 is going to be 7. Now let's look at D. G of negative 14. So again, I'm going to my G. I'm going to get 2 minus negative 14 plus 4. We're going to get, again, a double negative, so that'll turn into 16. The square root of 16 is 4. So 4 plus 4 is going to be 8. So G of negative 14 is going to be 8. Now one thing I want you to notice, on A through D, notice we were replacing x with numbers. So see how I got a number for my answer. Well, on these last two, E and F, notice we're not plugging in numbers, we're plugging in an algebraic expression. It's going to be the same concept. So I'm going to go to F. So I start writing F. I see an x, and it's telling me to replace that x with an x squared. So it's square that plus 1 minus 2. Well, now when we simplify this, x squared squared is going to be x to the 4th. And then I finish writing my function. In this case, you can't do anything else to this, so that would be your answer. So notice, because I did not substitute a number in, you're still going to get an algebraic expression as your final answer. Alright, let's look at F. G of x minus 2. So I'm going to go up to G. I start writing G. It starts with the square root minus. There's an x, so I replace that with an x minus 2, and then the plus 4 on the outside. Now to simplify this, you're going to have to distribute that negative. So when I distribute the negative, I get minus x plus 2 on the outside of plus 4. Now, excuse me, I can still go ahead and simplify that. 2 plus 2 is going to be a positive 4. So underneath the radical, I'll have 4 minus x, and then on the outside, I'll have a plus 4. So if you understand E and F, those would be examples of easier composite functions. So now let's talk about what is a composite function. So a composite function is always going to be in this notation right here, f of g. So it looks like fog, but you actually read it f of g. So I always like to rewrite it using this other notation on the right side. So the first function, notice, is always going to go on the outside. The second function will always go on the inside. And there's always going to be an understood x if nothing's written. Key here is we're still using substitution, and we're going to always work from the inside out. So you're always working from the inside out. So let's go ahead and jump straight into an example. So my first example, I'm given f of x is 2x plus 7, and then I'm given g of x is 5x minus 3. So now if I go ahead and look at part A, the first thing I'm going to do is rewrite this. So like I said earlier, the first function is going to go on the outside, the second function is going to go on the inside, and there's going to be an understood x. Now, like I mentioned, we're always going to work from the inside out. So notice on the inside we have the g of x. Well, what did we say g of x equals? Well, g of x is 5x minus 3. So, I'm going to go ahead, instead of g of x inside the parentheses, I'm going to go ahead and replace that with 5x minus 3. Now, we're going to do the same thing we did above. It's telling me to go to my f function. So I'm going to go up to my f function. Every time I see an x, I'm going to replace it with 5x minus 3. So go to my f. F starts with a 2. There's an x, so I replace it with 5x minus 3. And then finish writing f, so plus 7. Now we have to simplify, so I'm going to go ahead and distribute. Once I distribute, I can go ahead and combine like terms. So I'm going to get 10x plus 1. So you're saying f of g is 10x plus 1. Now let's take a look at part B. Part B, notice, reverses the order. So it's saying g of f. So that means g is going to go on the outside. F of x is going to go on the inside. Now, what did we say f of x was? F of x is 2x plus 7. So I can go ahead and replace the inside with a 2x plus 7. Now it's telling me to go to my g function, so I go up to my g function, I start writing that down. It's a 5. There's an x, but it's telling me to replace x with 2x plus 7. And then I finish writing g, so minus 3. Now I have to simplify that, so I'm going to distribute that 5. So I'm going to get 10x plus 35 minus 3. So I'm going to get 10x plus 32. So that means g of f is 10x plus 32. Alright, let's move right along to example 2. So example 2, again, I rewrite it first, so f's on the outside, g of x is going to go on the inside. Well, notice in this case, it's saying g of x is 7x plus 5. So I'm going to replace that g of x with 7x plus 5. Now it's telling me to go to my f function, so if I start writing f, it's 1 over 4, there's an x, but I want to replace that with 7x plus 5 minus 1. So I go ahead and simplify. I can't do anything to the numerator. I can go ahead and distribute in my denominator. And then if I combine like terms, I'm going to get 28x plus 19. So we're saying f of g is 1 over 28x plus 19. Let's take a look at B. For some reason, B can be confusing for some people because it says g of g. The process is not going to change at all. So g is going to be on the outside and g is going to be on the inside. So again, what are we going to replace g of x with? It says g of x is 7x plus 5. So now I go back to g. I start writing g, it's 7. There's an x, so it's telling me to replace it with 7x plus 5. I finish writing g and it says plus 5. So I'm going to get 49 plus what? 35 plus 5. So if I go ahead and combine like terms, I'm going to get 49x plus 40. So g of g equals 49x plus 40. So basically what g of g is saying is that you're plugging g into itself. Again, the process is not changing at all. I'm going to go ahead and stop the first video right here, and then we'll finish examples 3 and 4 on the second video.